Hey guys, so today we're going to learn how to simplify fractions. Simplifying or reducing fractions is the same exact thing, it's just different wording. So go ahead and take out your notebook and turn to your table of contents. For this concept, we are going to be having concept number 7, simplifying equivalent, comparing fractions. And like I said, I don't know what page number you guys are on, but don't forget to write your page number. So go ahead and open to your new page, and you are going to write your title as simplifying or reducing fractions. Go ahead and pause the video here so you can write down this statement. To simplify or reduce a fraction, you're going to divide both the numerator and the denominator. So remember from yesterday's lesson, we said, let's say that we have 2/3. My top number is going to be my numerator, and my bottom number is going to be my denominator. So what I need to do is I need to find the greatest common factor between my numerator and my denominator. So I actually have two examples here below. They're the same exact fraction, and I wrote two ways because there's two ways to figure to simplify these two fractions. And I'm going to do this way first. So what I'm going to do is if I can't come up with the greatest common factor between 12 and 54, here's a quick trick. Let's take the last numbers here. Are these both numbers even numbers? If they are even numbers, the number that you can always use is 2. If it is an even number, you can always use 2. But the thing is, you're going to have to continue reducing until you have the simplest form of your fraction. So I'm going to go ahead and reduce this by 2. If I reduce this by 2, 12 divided by 2 will give me 6. 54 divided by 2 will simply give me 27. Now I need to take a look at this fraction, and I have the factors of 6 are 3 and 2, and the factors of 27 are 9 and 3. So I know that they have a common factor of 3, so I still have to reduce this by their common factor, which is 3. 6 divided by 3 will give me 2, and 27 divided by 3 will give me 9. Now I have to take a look at this fraction and determine, do they have a common factor between here? Well, let's take a look. The factors of 2 is 1 and 2, and the factors of 9 are 1 and 9 and 3 and 3. So no, this is your fully reduced problem. Now this is the same exact problem, but you can avoid all these steps by taking the greatest common factor between 12 and 54. To do that, we really need to know our factors here. So I know that the factors of 12, and I'll write this here, you can always start with 1, and then 2 is another factor, 3 is another factor, 4, 6, and 12. So these are the factors of 12. Now let's do the factors of 54. Factors of 54, 1, now let's take a look at our practice here. So I wrote down 8 questions here, and what I want you guys to do is I want you to pause this video and write this down and figure out how do you solve all of these fractions by reducing. Right, so the first one, I noticed that they both end in even numbers, so I can use 2 to reduce this, but I know that they have a greatest common factor of 4, so I can always just reduce it by 4, and that would give me 1/4. Perfect. Next, once again, I know I can use 2, so let me go ahead and use 2 just because they're even numbers. I have 5/13. 13 is a prime, and as is 5, so that is a fully reduced problem there. Number 3, and 3 is a little bit tricky because in this thing we can either divide 18 divided by 18 will just give us 1, or you can also divide 18 and 18 because it is your greatest common factor. You'll still get 1/1, which is just 1. Right? You can do both ways. It's totally fine. Number 4, my greatest common factor between 6 and 27, that would be 3. 6 divided by 3 will give me 2. 27 divided by 3 will give me 9. Yep. Number 5 is pretty cool. I really love these type of problems because what you can do is you can just slash those zeros together and you just reduce your problem. You don't have to think about it. Wherever you have the zeros, slash the 0. So that means that your answer is just 1/4. Or if you just want to do the old-fashioned way, you can just divide side by 10. 10 divided by 10 will just give me 1. 4 divided by 10 will give me 4. That's it. Number 6. I'm going to reduce both of these numerator and denominator by 7. So I got 1/4. Question number 7, same idea. I can slash those zeros. As long as I have zeros on the top and on the numerator and denominator, I can just slash them down. So my answer is just 2/5. Last, I have 12 and 20. I know I can use 2 to reduce this. 12 divided by 2 is 6, and 20 divided by 2 will give me 10. Taking a look at this, I'm still not done because I still have even numbers, so I'm going to continue reducing it by 2, and that would give me 3/5. Next, we're going to talk about equivalent fractions. So go ahead and pause the video now so you can write down our first section right here. So what equivalent fractions are fractions that name the amount in different ways. So it's like saying that I have here in this first section, I have 3, 4, right? So I have 4 little columns, but I've only shaded in 1. So that means I have 1/4. Here I have 3, 4, 5, 6, 7, 8. And I've only shaded in 2 of those squares, so I have 2/8. Here I have 3, 4, 3, 4, so that's 16. And I've only shaded in 4 of those squares. And so what I'm trying to prove here, I'm trying to prove that this is equal to this, as this is equal to that. By taking all of these fractions here, if I reduce 2/8, so I reduce it by 2, I get 1/4. If I reduce 4/16, I also get 1/4. They are all equivalent fractions. Just because they have more blocks inside doesn't make much of a difference. It only states like, I'm cutting it into more pieces, but I'm still hiding the same amount. Next statement states, to find equivalent fractions by using division, divide the original fraction by the common factor of the numerator and denominator. And that's what I did. I just used my common denominator here, and that's how I got 1/4. I used a common denominator here, and I got 1/4. So below, we're going to have a couple of examples that are considered to look like proportions, and I want us to understand what proportions are now before we get a little bit stuck in the future. Oh, let's do this question right here. Let's do this quick example. 30 divided by 42. So in order to reduce this fraction here, I need to find a greatest common factor here. So I know that the factors of 30 are 5 and 6, and I know the factors of 42 are 6 and 7. So they have a greatest common factor of 6. So I divide 6 on the numerator and denominator, I'm left with 5/7. They are both prime numbers, so I don't need to do anything else. When we get down to our practice here, I have 6 problems that I wrote down, so go ahead and pause the video so you can write all these problems down. What the directions say is find the missing numerator or denominator. And so what I'm going to ask you guys to do is you are going to plug in the variable of x. Whenever you have a missing value, you're going to plug in x. And this is where proportions come into play. What a proportion is you have 2 fractions and you need to figure out what that value or that missing value is. And the fun and easiest way you can do it is by multiplying, by cross multiplying. And so what I'm going to do is I'm going to circle what you need to multiply. Actually, I should have done a different color. I'll circle this and this. So this is what's called cross multiplying. You see that x right there? So it means where you see the highlighted pink, 12 times x will give me 12x equals, because that's the equal sign in the middle, with the blue circle, 3 times 4 gives me 12. Now we're going to use the order of operations to solve for that missing value. So 12 times x, any 2 terms side by side means that they're multiplying. The inverse of multiplication is division. So what I'm going to do is I'm going to divide each side by 12. And I'm left with x is equal to 1. And if you still get like a funny number, you can always plug in your value of x. I plug in 1. I have 1/3 here. And if I go ahead and reduce 4/12, I would just get 1/3. And 1/3 does equal 1/3. Let's go ahead and do this again. I'm going to highlight my first section here, cross multiplication. So that means 30 times 1 gives me 30. And then I'm going to highlight my next section. 2 times x will just give me 2x. And don't forget about that equal sign. Now, like I said, we have to understand two terms side by side means that they're multiplying. So what's the inverse of multiplication? Division. So I'm going to divide each side by 2. 30 divided by 2. If you don't know your factors that well, just think about money. So what's half of $30? 15. So that means that I have 15 is equal to x. And don't worry about x is equal to 1 or 15 is equal to x. We're going to learn this in a few units later about our properties. So they mean the same exact thing. Once again, let's go ahead and find the value of this x. 2 times 3 will give me 6. And 1 times x will just give me 1x or x, however you want to write it. I just like writing x, just to avoid any confusion. And that is my answer. And if you plug it back in, you know that you have 3 over 6 now. So you can reduce this by 3, and you're left with 1/2. 1/2 equals 1/2, so that makes sense. Now we're going to get to a couple of tougher questions here. I'm going to multiply 60 times x, and that's just going to give me 60x. We're going to multiply 12 times 5, and try to remember your 12s. 12 times 5 will give me 60. This one's pretty cool. Remember, two terms side by side means that they're multiplying. The inverse of multiplication is division. So you're going to divide each side by 60. And if they have the same variable and same value, cross that out. And here you can just remember reduce this. We'll cross out the zeros, and 6 divided by 6 will just give me 1. X is going to equal 1. Here you could also just say 1x equals 1. It's the same exact idea. Next, 6. There we go. Put it as a 7. 6 times 7 will give me 42. 21 times x will give me 21x. Divided side by 21. X is going to equal 2, because 21 plus 21 will give me 42. So, last question here. Cross multiply. 20 is going to equal 5x. Divided side by 5. If you divide $20 5 times, that would just give you 4. So 4 is going to equal x. And that's pretty much it. Go ahead and turn to a new page and pause and write down comparing and ordering fractions as the title of this page. There are 3 steps that we're going to go over really quickly. They're steps that we've already done before. And so what we're doing here is that we're going to take fractions and we're going to try to find basically comparing and which one's higher and which one's lower. In this case, we're given 2 over 3, 7 over 12, and 5 over 8. What I'm going to do here in step number 1 is we're going to find a common denominator. And what we're going to do is we're going to find our least common multiple. By finding the least common multiple, I'm going to make all of these denominators into the same denominator. And I'm going to do this here on step number 2. We're going to find equivalent fractions using the common denominator. And so what I'm going to ask you guys to do is you're going to write out the multiples of all of these numbers until we find a common denominator. So the multiples of 3, remember you always start with itself. 3, 6, 9, 12, 16, 28. Sorry, I don't even know why I put 16. 3 times 5 is 15. 3 times 6 is 18. That's what I get for going too fast. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. And 3 times 10 is 30. Okay. Next, I got the multiples of 12. We always start with itself. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. And then 48. And I'll stop there. Next, the multiples of 8. We always start with itself. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. and 8 times 4 is 32. And so what I need to do now is I need to find a common multiple. And so if I look at here, it's like, okay, well, none of them have a 3, none of them have a 6, none have a 9. They do have a 12. Nope, not all common. 15, no. 18, no. 21, no. 24, let's see. Yep, they all have 24 in common. So I'm going to highlight that. 24 is going to be our common denominator. And so in order for us to figure out, okay, well, I need to make all of my denominators 24. And so what I'm going to do now is I'm going to bring all these numbers down here. I'm going to have 2 over 3. And in order to make this denominator 24, I need to find the factor that makes my denominator 24, and that's going to be 8. And what I do to the denominator, I got to do to the numerator. So that means now 2/3 will now be 16 over 24. Next, we have 7 over 12. I need to figure out the factor that makes my denominator into a 24, and that's just going to be 2. And what I do to the denominator, I got to do to the numerator, that's going to give me 14 over 24. Last, I have 5 over 8. I need to figure out how to make this into 24. That means 3. I have 15 over 24. So now these are my new fractions. And what I'm going to do is I'm going to compare them here on the top. So now for 2/3, that's going to be 16 over 24. For 7 over 12, that would be 14 over 24. And for 5/8, that would be 15 over 24. Now that I have my common denominator in both of these fractions, now I can just write my inequality signs. And it's going to be super easy because they all have the same number of squares. Now I just have a couple of more squares shaded here, a couple of less squares here, and a couple more here. What I need to do now is I need to figure out where do my inequality signs go. So that means, is 16 greater than 14? Yeah, it is. 16 is greater than 14. Is 14 greater than 15? No. And these inequality signs are a little bit different, but now let's go ahead and put them in order. So who it goes first? All right, so I have 16 is going to go first. Now I have 15 as second, and 14 as 24. Let's start. So I have a couple practice problems on the bottom. So go ahead and pause so you know exactly what to do. Practice. Compare the fractions by using your less than or greater than or equals. So if they're equal, just write equal. If they're less than or greater than, then make sure that you're putting in correct inequality. So here it's just going to be easier. I just have 4 problems and they have each 2 fractions. I need to figure out who's going to be greater and who's going to be less than. So what I want you guys to do is get used to having a common denominator. So let's go ahead and find the common denominator between 4/12 and 1/2. So I need to make this into a 12. In order to make this into a 12, I got to multiply this by 6. And so now my new fractions that I'm dealing with is 6 over 12. Now who's greater, 4 or 6? 6 is going to be greater. And that's it. That is my answer right here. Next, here I need to find a common denominator. And to find the common denominator, for me it's really easy to look at this because I know all my multiples and my factors. I can figure out would be 48. And so what I'm going to do is I need to figure out how to make these into both 48. So I know that 12 times 4 gives me 48, and what I do to the numerator, I do to the denominator, and 8 times 6 will give me 48. So that would give me 48 here, 48 here, and that would give me 44 and 48. I know this one was pretty straightforward, but just to make our section as we wanted to answer, I know that 48 is greater than 44, so 48 is going to be greater than. Next, I need to figure out here, like, who is my greatest, or who's my least common multiple here to find my equal denominators. Because this is an 11 and that's a 4, I know that I can turn this into 44, and I'll make this into an 11. So I'm going to go ahead and do multiplication really quick. That would turn to 22, 44, 44 over 44, and that means that 44 is greater than. So, next, I have 1/2 and 1/6. You can just tell that 1/2 is going to be greater than, but because of the section that we're doing, I want to make sure that we fully understand how to find common denominators here. So, in order for 2 to turn into a 6, I need this to be a 3. So I have 3 over 6, and I have 1 over 6. 3 is greater than 1, so that is my answer.